The first way we can control the schema of our database is by using attributes that are coming from the System Component Model Data Annotations namespace. You may have seen these attributes before. Let me quickly add one on the title. Let's assume the title can only be 128 characters long. Then we add a max length attribute. And if you're familiar with ASP.NET Model Validation, you may have seen these exact same attributes before. Because System Component Model Data Annotation is not specific to Entity Framework, it is a general data validation set of attributes. So max length is the one that will fix the length of our title field. It will also help us find that missing primary key by saying that this is the key. Now there is a second set of data annotations, and they live inside in a sub namespace, and they are the data annotations schema attributes. The schema attributes are used for anything that affects the storage schema of the things that we are using. For instance, if we want our title field to be stored as a varchar, we can do that with the column attribute, and the column has a type name field that we can set to varchar so that we're not using nvarchar anymore. We can also use it to change the names of tables and columns. Remember that this was stored as movies. We can very simply store that as pictures by using the table attribute. So in our database, it will be called pictures, and in our model, it's still movie and movies. We can do the same for columns. Let's say that we want to call synopsis plot in the database. We can very simply use the column attribute again and use the first parameter, which gives it another column name. So we call it plot. We can also use this in one go and say type name equals, let's say that this one we do want to have as a varchar max. We can do it just like that. For release date, we're not using the most efficient data type because we're using a datetime2, and we only care about the date part of the release date. So we do column, and we do type name again, and that is going to be a date. Now, if I were to run this, we should see the changes in our database, because remember, we do have that hack in place that drops and recreates all of our tables whenever we run this application. So when I run this now and we open up our Azure Data Studio, we're going to have to refresh the tables, but we're going to see what Entity Framework did with this. So let's take a look in Azure Data Studio. Let me refresh the fields. I'm actually going to refresh all of the tables. We see that we now have a table called pictures, and we see that it has a correct primary key called identifier. Title is a varchar 128 and plot is a varchar max. It all worked out the way that we hoped it would. There is one thing that we can still control that I think you should really know about before we continue is this is now nullable in the database because we have a nullable string in our model, but we can actually let those two deviate from each other as well. So let's say that we don't want any movies to make it into the database without a title, then we can go into our code and set the required attribute on this one, and that will make sure that in the database it will become non-nullable. So I'm just going to rerun it and refresh my Azure Data Studio as soon as the application has started, and you will see what has happened right away. And you will now see that the title field is non-nullable. Now there's a couple more attributes. Some of them will not have an effect on the database because, as I said, these are generic data validation attributes. So a min length, for instance, does not exist. It's not something we can do. It will not have an effect on the database, but you can still use those attributes on your code if you would like for other reasons. So that's the first way of doing this. Let's move on to the next one. Now, whether you like the way this looks or not, that doesn't really matter. That's a personal thing. But to me, there are two problems with this code. First of all, we are adding a lot of persistence logic in the form of all of these attributes to what is essentially a domain class that we can use in the rest of our code base. So either we map it to something else or these attributes don't belong here. The other thing is, if we are switching between different database engines with our application, let's say that you release a piece of software that has to work on both SQL Server and Oracle, some of these are going to be database engine specific because different data types may have different names in different database engines. So in all of that can be fixed by using the other way of doing it, which is my preferred way of actually mapping and changing the database schema anyway. So I'm going to remove all these polluting attributes from this class, and we are going to see the other way of adjusting the database schema with Entity Framework. So all of this can just be gone, and we're going to move the mapping code to the place where it belongs, closer to where the data actually gets persisted. In our case, the DB context, and we're going to override another method. We're going to override the onModelCreating. Now, onModelCreating is a method where we can feed Entity Framework information about the mapping between the code and the way the database looks. So everything it cannot derive from the conventions or any conventions that you want to override, you can feed Entity Framework that info here. And this method gets called once. The first time that we create a database context of a certain type. So the first time we create a movies context in our code base. Now the first time that gets called, we actually run the onModelCreating to build the mental model of Entity Framework, and after that it never gets called again. So the code that we write here has an influence on our model, and the model builder is the key to it all. The model builder is actually a real builder pattern where we have methods for everything we want to do. So we start with configuring an entity, in our case the movie entity, and everything that is related on entity level we can configure here. Now remember that we wanted to store this entity in a table that was called pictures that we can do with the toTableBuilder method. And we can just go pictures here, which is fantastic. Now this returns the builder again so that we can add even more configuration to our table. We remember that we didn't have a primary key that was found by convention, so we can configure it here. So we can say hasKey, and we can either pass the string name of the property, or we can do something strongly typed with a lambda expression. We can just go movie.identifier. Exactly. So that fixes that. So now it's already being stored in a table called pictures, and it has a primary key that is being found by this mechanism. Now, if we start configuring properties, there are property builders for every property, but those property builders we can get from the entity builder. So I'm going to start with the entity builder, just like here, and we will call the .property on this. And that will get us the property builder. Now there's a generic property builder, but the easiest way to do this is extract a property builder with a lambda expression again. So we can just go movie.title. And title is the class that it was the property that we had most configuration for. We are going to store this as a varchar, and that is done with the hasColumnType. And hasColumnType, we can pass a varchar into that. It's also limited to a max length of 128, so we can just do hasMaxLength 128. And we can do, the last thing is that we wanted it to be non-nullable in our database, which is done with isRequired. And that configures our property. If we want to move to the next property, we're going to have to call a property builder again. So I'm just going to copy these two lines for the last two properties that we had. We are going to configure the release date, and that is going to be a date in the database, which is all that we need to do for that field. And then we will do the last one where we wanted to move it to a different column name. So it's called Synopsys in our code base, but it's going to be a varchar max, and we are going to store it in a column, has column name, and we can basically call it plot right here. So everything that we had in attributes before is now here. It's all on our screen. And this is basically in another place where it makes more sense. So if we execute this right now, we're going to get exactly the same database schema as we were getting before. So let's take a look at what we got. We can basically open our Azure Data Studio again, and we can refresh this, and nothing will have changed. We still have a table called pictures. The primary key is called identifier. That is not null and 128, and so on. But you can already feel that this could be an issue, because if we go back to this code base, we are writing everything for every entity in a method called onModelCreating. That's going to get chaotic really quickly. Now, this is not the recommended way of doing this. You can basically configure every entity for itself, and you can do that in separate files. I'm going to show you how to do just that. So first of all, what I always do is create a folder to hold all of these configurations. And if you have a product that supports multiple database engines, you may end up with multiple folders, one for each of all of the mappings for a certain database. But for us, it's just going to be entity mapping for now. I'm just going to call it something like that. And I'm going to create a first class for my first mapping. And that is going to be for the movie entity. So I'm just going to call it movie mapping. Now, there is an interface that we need to implement to make this happen. And that comes with the Entity Framework package. So it's nothing fancy. It's called iEntityTypeConfiguration. Type configuration, and in a generic type parameter you can pass the model class, so in our case movie. Now if we implement this interface, let's first import the namespace for movie. If we implement the missing members, all you're going to get is a configure method, and what you're getting is an entity type builder of movie. Now let's go back to our original DB context and let's take a look at what we're getting from this entity class. What we're getting there is an entity type builder of movie. So everything we have written here against model builder.entity movie, we can write against that builder in that other class. So I'm just going to take all of this code and move it to that newly created class. And instead of doing model builder entity, all I can do here is use builder. So I can just take this line and replace it with builder. And for all of the property ones, I can just do something like that. Now, all of this code is there, but we're still going to have to tell our DB context about it. So we're going to go back to our movies context. In the onModelCreating, we're going to do model builder. And we can do either, we can apply separate configurations one by one, or we can apply all of the configurations from a certain assembly. Now, if you're supporting a single database engine, usually you're just going to want the second one and apply all of the configurations from an assembly. If not, if you're supporting different engines, you're going to have to write a little bit of code to figure out which configurations you're going to be loading. Now, it's not really, I'm going to apply them separately for now. We're just going to make a new movie mapping. So movie mapping is right there. And that is the way that we can tell our DB context about this code being executed. So if we run it right now, we will get the same database, the same looks, and we will have the mapping for each entity in a separate class, and we can keep it all nicely separated. This is the way that I prefer to make all of my mapping for my database schemas.